Greetings everyone, welcome back to a new video. Today's topic is about quicksort but using two pivots. In this video, we will discover an algorithm which is similar to the Lomoto algorithm, which will be used to partition the array using two pivots. So in order to understand the partitioning of the Lomoto algorithm but for the two pivots, we shall see the following cases. We shall pick two pivots denoted as P1 and P2, where P2 is always greater than P1. We have the following cases. The numbers of the array may be less than P1, so they are also less than P2. The second case is the numbers are between P1 and P2. The last case is we have numbers that are greater than P2, which are also greater than P1 because P2 is greater than P1. In my code, I chose the pivots to be the last element and the first element of the array, but you can choose any pivots you want. After choosing the pivots, we compare the two pivots. Here, 4 is less than 6, so 4 is P1 and 6 is P2. After comparison has been made between the two pivots, we move the greater pivot to the last element of the array and the smaller pivot to the element before it. So now we shall start running the algorithm as follows. Now the following will address the first case scenario we have, which are the numbers that are less than P1. In our case, P1 is equal to 4. So we start iterating. L is now pointing to 7. 7 is greater than 4, we continue. The same goes for 10 until reaching 1. 1 is less than 4, so we swap 1 and 7 after incrementing I. We continue the for loop. L is now pointing to 2. 2 is also less than 4, so we swap. Also continue reaching 3. 3 is less than 4, so we increment I by 1 and we swap. We continue the for loop. 5 is greater than 4 and 11 is greater than 4, so we stop. Now we swap 4 with its correct position in the array, which is we'll swap 4 with 10 with I plus 1. Now we mark the position where 4 is now residing in the array, which is 3. After checking for the first case, we should check for the second case, which are numbers between P1 and P2. So we continue iterating with now I pointing to the first pivot's location. L now is pointing at 7. 7 is greater than 6, so we don't swap. We continue. 5 is less than 6, so we increment I by 1 and swap 7 with 5. L now continues to the rest of the elements. 11 is greater than 6 and 10 is greater than 6, so only 5 is the number between 4 and 6. So now we should place 6 in its correct position, which is to swap it with the element that comes after 5. So we swap 6 with 7. As you can see, we have partitioned the array into 3 parts: the numbers that are less than P1, numbers that are between P1 and P2, and the rest of the numbers must be greater than P2. So now, instead of placing one element like we did in the quicksort in its correct position, we have managed to place 2 elements in their correct position, which are the 2 pivots, 4 and 6.
So guys, here is the C++ code I've written for you to see. First, there is the main method, which is called 2pivot quicksort. It takes an array A and add 2 pointers P and R, which will be pointing to the beginning and the end of the array. It first calls the partitioning algorithm P and R that will return a vector of 2 elements, since we are placing 2 elements in their correct position. Here is the algorithm I have explained before on the board. It takes a vector A and 2 pointers P and R. It first swaps the 2 elements based on which one is bigger and which one is smaller. It places the bigger pivot in the last element and the smaller pivot in the element before it. Here is the first case for the partitioning. It first checks for the elements that are less than P1, which are pivot 1. It swaps those elements. Then it saves the pivot's first location at an index I. It swaps the pivot back to its location where it should reside in the array. Then it checks for the second case, which are the numbers that are between pivot 1 and pivot 2, as you can see. When it finishes, it also swaps the element back into its correct position in the array. It initializes a vector of 2 elements, and the first element of the vector will be the first pivot location, and the second element is the second pivot location. These locations represent the real locations where the element should reside in the array. Then it returns this vector. After returning this vector, we have two pivots, Q1 and Q2. So the recursive calls must be 3. One recursive call must call the elements that are from P to Q1 minus 1, because we have placed Q1 in its correct position. The second recursive call is from Q1 plus 1 to Q2 minus 1, which are the elements that are between the pivot 1 and the pivot 2. And the last recursive call are the elements that are greater than pivot 2, which will be represented from Q2 plus 1 into R. These recursive calls will be solved using the same algorithm, the partitioning algorithm I have explained, until P is no longer less than R. So now let us try this algorithm. First, we enter the length of the array. Let's say 9. We enter the numbers. As you can see, the sorted array is 0, 1, 1, 3, 4, 6, 8, 9, and 90.
This has been the CS Tutor. Thank you for watching. If you have any question, put them down below and see you next time.